Assalamualaikum and welcome back to Technology Explore. This is the part number 8 of SolidWorks Complete Learning course, and in this video we will talk on the in the advanced mates we will learn the distance mate and angle lock mate. Then we will talk on mechanical mates and gear mate and screw mate. So stay tuned. Now first of all, let me show you. And basically the distance lock mate is used to lock the travel of a component to a certain distance specified by the user. So let me show you an example. For example, I'm going to move this part up to this point and this point only. So for that, first of all, making a coincident mate of this face, select this face and then select mate, then select this face. Now flip the mate alignment from here, then press OK button. Then select this face and this face, make both these faces parallel to each other. Press OK button. Again press OK button. Now you can see here we can move this part like this. But I'm going to make the movement of this part locked between these two points. So for that, click on mate, then advanced mates, and in the advanced mate select distance mate, and then select any of the two faces. So let's select these two faces. Then here you can see maximum distance. So type here maximum distance. Let's say I'm going to select 600 millimeter maximum distance, and minimum distance let's say 30 millimeter. So here is the current distance. At the moment it is 30 millimeter. So you can increase or verify the distance. So let's select 600. Instead of 600 maximum distance, type here 400 maximum distance, and minimum distance select 50 millimeter. Now you can also type here 400 millimeter to verify. So now if you press OK button, then this mate will be applied, and now you can check. So this part is the movement of this part is locked between these two distances. So maximum distance from this face to this face is 400 and minimum distance is 50 millimeter. You can also edit this mate by expanding the mates option from here. Then here you can see limit distance mate. Click on it and then edit feature, and you can apply new settings, and then press OK button. Again press OK button. So this was the limit distance, and the another mate is limit angle or lock angle mate. So the limit angle mate is also used to lock the rotation of a component between the certain angles specified by the user. So let me show you. First of all, let me delete this limit distance, then also delete this parallel, and let me delete this plate. Now if I have to rotate this part, now if I click this only line, not this face, only this line, press and hold control key, then select this line, release the control key, and then select coincident. Also select this face and this face, make them coincident or parallel. Now let me fix this plate. Then here you can see if I try to rotate, the selected component is fully defined, because we had also created the coincident mate of this face with the face bottom face of this component. So we have to delete it. So click on this component and then select view mates. Then we have to delete this coincident mate. now you can rotate it. Now you can see this part is rotating 360 degree, and now I'm going to log the rotation of this component along with this with respect to this face. Let's say 30 degree minimum and maximum, let's say 75. So for that, again click on mate option here, then scroll down advanced mates, and from here limit angle mate, select it. So this is the maximum angle, this is the minimum angle, and so select the desired faces, this face and this face, and type here maximum minimum distance, let's say 15 degree, and maximum 75 degree. Then press OK button, again press OK button. Now you can see 75 is the maximum and minimum 15 degree. So now we are able to make the rotation of this component fixed on this part. So this was the limit angle mate, and you can also edit it by clicking on this limit angle 1 and then edit feature. Now we have the mechanical mates here, and in the mechanical mates I'm going to reveal gear mate and screw mate. So for that we have to create a new assembly. First of all, let's start from new assembly again, then press escape button. Import the gears if you had designed the gears in separately or by yourself in SolidWorks, but I have another option to import the gears. That go to design library, then select toolbox, and then from here click on this add-in now, because add-in toolbox add-in is not turned on. So to turn it on, click on this button. Now from here select the standard, so let's select NC metric, then from here power transmission, then these are the gears. So here are the type of gears. Let's say I'm going to use helical gear. Click and drag it into the assembly and wait for a while. So here you can see these are the options related with the gear. So this is the module. Let's select module module 2. Then after the module we have number of teeth option. Let's select number of teeth 20. Then helix direction, right hand or left hand. So select right hand for this. Then this is the pressure angle or helix angle. This is pressure angle, and this is face width. Let's say 10 millimeter is the face width, and this is hub style, one side, both sides. So choose your desired hub diameter. Let's say 40 millimeter. This is the overall length of hub, and it should be 20 millimeter. And this is the nominal shaft diameter. So this diameter, nominal shaft meter, select it. Let's say 15 millimeter, and again scroll down. Keyway, if you want to create keyway scale 1 or scale 2, select your desired keyway, then show teeth 20 and press OK button. Now we had created this gear by using design library. Again we have another we have to import another gear. So for that, again click on design library here, then click and drag helical gear. Leave all the settings as they are according to this gear, but instead of helix direction, change it from right to left. Now press OK button. Now again press escape button. So first of all we have to hide this sketch. Right click on this sketch and then hide it. Similarly, hide this sketch. Hide it. Now, if you can see, I am able to move this part, but I am unable to move this part because this part is fixed. So to make it float, right click on it, then select float. Now, let's make some mates. So for that, select right plane, then select mate, then select this face and press OK button. Then make the coincident mate, then press OK button again. Again select this face and press and hold control key, then select this face. Now select coincident mate. Now you can see I can rotate this part, and when I try to rotate this part, the part is moving instead of rotating. So for that, click on right plane, then sketch on it. Make normal to, and then draw a line. Start it from origin like this. Press escape button. Then press this button to save and exit from sketch mode. Then click and drag this gear to align it with the another gear like this. Now again select this line and edit its sketch. Now click and drag this line like this. We have to align this line perpendicular or vertical to the center of this circle. Then right click on this or right click or just click on this point, then make it fixed. Now save and exit from sketch mode, then select this point, then this cylindrical face. Release the control key and from here select concentric mate. Again press space key, then select this view orientation. Rotate the gears to align them like this. So now we have fully defined the assembly of these two gears. So click on this line and hide it. Now it's time to make the gear mate for both of these gears. So for that, click on mate, scroll down, and from here mechanical mates, select gear mate. Select this cylindrical face and this cylindrical face. Select the ratio from here. So if you have 1:1 ratio, we have 1:1 ratio for both of these gears because both of these gears are of the same size. Then do not check this option, reverse, and press OK button. Again press OK button. Now rotate one gear, and you can see we are able to make the gear mates in SolidWorks. So next we have the screw mate in the SolidWorks. So for that, again we have to start from a new assembly. So for that, click on new button here, then select assembly. Now import the bolt and nut in the assembly. So this is the bolt and this is the nut. Press escape button. Now click on this this bolt, and to make screw mates, we have to make a reference for the bolt, and that reference could be an axis on the bolt. So let me show you how. Click on this part and open it in a new window, and then now click on reference geometry here, and then from here select axis and zoom in, then select this cylindrical face, and here you can see we had created the axis. Press OK button and then click on this point and increase the length of this axis like this. So click on this I button here, and from here select or view axis. Then go to assembly, and from here also select or click on this arrow in front of I button, and then from here select view axis. Now we are able to make the screw mate for this nut and bolt. So again select mate, scroll down, and then from mechanical mates select screw. Now if you scroll up, here you can see mate selections. So select this axis and then this cylindrical face or this circular edge. Scroll down, and here you can see the option revolution per millimeter and distance per revolution. So you can type here the pitch or any of these two options. So let me select distance per revolution, and it is 1.25. Press OK button. Again press OK button. Now if you try to rotate this bolt, this nut, and you can see so now you can see the screw mate has been applied and it is working perfectly. So let me hide the axis, and then you can see if I rotate this nut, and it is working perfectly. So this is how we can apply screw mate in SolidWorks assemblies. You can also edit it by expanding the mates option and then click on it and edit feature. I hope you had enjoyed and learned from this video. If you like this video, please subscribe to my YouTube channel, and thanks for watching and sparing time.